Hello everyone. In this chapter, we talked about security and privacy aspects in cloud. As an introduction, I can tell you that there are two disadvantages, two drawbacks with cloud systems. Unlike all other advantages that we discussed over the semester, there are at least two disadvantages in cloud systems that you should know about. One disadvantage or one problem is the high latency in cloud systems. That means the turnaround time from a request, from issuing a request at the user side up until the user gets the result, the processed results back, is considerable. Maybe this turnaround time for let's say web-based applications or many applications is negligible. It's a matter of seconds, which is, let's say, in case of online purchasing or many web applications, video streaming is negligible. However, for certain applications that need very low latency, it's not tolerable. Just imagine a smart vehicle that needs to decide about its next action, and it needs a very low latency decision, or the decision should be communicated to the vehicle in a very short time with a very short latency, such that it can operate safely. Otherwise, if there might be accident, 1 second is a very long time for critical decisions. So therefore, high latency is one problem of clouds. And if you ask why, the reason is in the nature of clouds. So clouds naturally are very centralized. As we discussed, the cloud comes in forms of data centers that are located in certain areas, and there are not so many of them. Of course, there are so many of them, but still, with respect to the whole, let's say, country or continent or the whole world, they're considered centralized. So this causes the network latency plus the computation latency adds up, and that causes the high latency of cloud systems. To overcome this latency problem, there has been a solution over the past few years, has become very hot. That is known as edge computing systems, also known as fog computing, FOG, fog computing systems. The reason that it is called fog computing or edge computing is that you can imagine that clouds are top in the sky, and then fogs are kind of closer to the ground, to the users. So same idea is here. Instead of having clouds very far away, having some fog, some clouds coming to the user, coming to the close to us, and therefore have low latency, more localized, and less latency. So that edge computing nowadays is becoming a big topic. A second problem that cloud systems have is the security issue. That is even more important. Not many applications can use clouds if there is a security concern, and there is security concerns with that. The reason is that you outsource your data, your computation to somewhere that you do not have control over, and that makes the system very much prone to attacks, to kind of uh, reliability problems, and all type of security and privacy issues. So in this chapter, our goal is to discuss that aspect. Our goal is to learn about security threats in clouds and examine what security tools we have to make the cloud secure. Okay, so let's talk a little bit about the basics of security. When we talk in the security domain, we need to be familiar with this terminology. One of the common terminologies in this context is threat or threat model. A threat model is basically identifying the security problems in a system. So, for example, the type of attacks that can occur in a certain system is the threat in that system. For example, because we store our data in cloud, the storage of data, uh, the data may be attacked. For example, uh, can be tampered with. So that is a threat model. So this is basically threat modeling is a first step in security of computer systems, and in this case, cloud systems. Once we identify the threat model, we need to choose a mitigation tool, a tool to cope with that security issue. And then using that tool or combining several tools, we build solutions. So we have tools and we have solutions. So what type of attacks can occur in the context of cloud? Two main attacks are possible, or two categories: internal attacks and external or stranger attacks. So insiders versus outsiders. Uh, the most of you are familiar with with both types of attackers. However, I want to emphasize that in the case of cloud, probably the major concern is from internal attackers, who can be the data center staff, the cloud staff, or the cloud itself, although it is a little bit unlikely, but it happens. But the major concern comes from the staff that have access to almost everything, many of them. And then it is critical to protect your data and computation against such attackers. Okay. Um, Stranger or external attackers are also there. They are the type of attacks that they perform is generally different. For example, external attackers most of the time do DOS or DDoS attacks, denial of service, in which the attacker tries to just disturb your system such that its performance, its response time drops. Okay, what do attackers attack, specifically in the context of cloud? In the context of cloud, we are concerned about three uh, types of attacks or three assets that might be targeted. One is the confidentiality of the data. So basically, the data, the attacker may not change any, may not apply any change in your data or in your computation, but just gets aware of those data, and it's like someone watching you without you knowing that. So also it is possible that the integrity of your data or computation is attacked, such that they actively go and change your data without probably you understand that. And of course, availability, which means that they target the availability of your services and try to do some attacks that your data might be still confidential or the integrity is intact, but they are not available. Okay, so there is a wide variety of mitigation techniques that can address different types of threats. Well, the discussion of how these tools work and all that is beyond the scope of this class. However, this table summarizes some of popular threats and the mitigation techniques for them. For example, if there is a spoofing identity problem, the mitigation technique can be a combination of a good authentication method plus not storing secrets in the internet or in the cloud. If you have integrity problem, tampering with data, again authorization, hashing, and digital signatures together in some fashion can overcome this problem. All right, but let's zoom on the cloud specifically and see what new threats have been exposed or basically created in the cloud domain, because security is not a new issue. Even without clouds, at the age of internet, or even before that, there has been security issues all the time. But what are the aspects that cloud introduced to the security domain, and why? Why is this happening? I mean, what change cloud has made that makes the security even more serious and more important issue? So the thing is that without clouds, in other words, in just internet, we just do information retrieval. It's just retrieving information. So people or attackers only have access or target your data. But in the case of cloud, in addition to data, we have computation, we have databases, we have queues between different services or microservices, which means computations, and therefore there is a larger area of exposure, and it is more prone to different types of attacks. Another problem or security problem caused by clouds is the issue of multi-tenancy. So multi-tenancy, we talked about it in the past. It is the issue that a hardware system or a resource in general can be utilized by multiple users at the same time. So in addition to adding uncertainty to the system or to the applications, this can have security implications as well. And eventually, the cloud themselves are not trustworthy because it's a third party, it's not under our control, therefore it's hard to 100% trust on them. So, and there has been incidents such as PRISP not a couple of years ago, more than that, in 2013-14 timeframe, that around 6 years ago, that basically cloud providers were compromised and they revealed users' information. So after that, the issue of security in cloud become more prominent, and then it proved that clouds are not trustworthy. After that, more businesses are feeling uncomfortable to deal with clouds. Okay, in the rest of this section, what we will do is basically reviewing some major security issues in clouds, in different types of clouds, and discuss potential solutions for them. So, because our main discussion in this course was on infrastructure as a service clouds, we start with infrastructure as a service or IaaS security problems. So yes, we mentioned that the main problem is that cloud is a black box. That is why we cannot rely on what is happening inside that. Of course, this can be attractive because it abstracts us from a lot of challenges that otherwise we have to take care by ourselves. But in this case, cloud is taking care of it. But it comes with its costs. You lose your control over the data. So let's say in case of infrastructure as a service, attackers, which as I said are generally or mostly insiders, insider attackers, can access to your virtual machines and compromise the confidentiality and integrity of your data. So what are our approaches to deal with security in IaaS clouds? First approach, that is probably the most common one, is just ignoring that and pretend that nothing has happened. So surprisingly, that is the most common solution too. In general, if you have a small business, if you are not a big competitor of big companies, probably there is not much to be concerned about. The problem starts for bigger companies, for major competitors, that the security issue becomes more prominent. Therefore, an ideal solution for such clients of clouds, big companies specifically, is the ability to audit the cloud resources. So the users ideally should be able to audit the resources that they are given to, and then they can check if those resources have been compromised, and if not, they can be used. But this approach has some problems. The issue is that cloud providers often, if not always, are not willing to share this type of privileges to users. A third approach can be using third parties. There are already third-party companies that have relation with the cloud provider and have some agreements with the users, and they try to provide some more security or auditing activity ability to cloud resources. But even this approach is not very common because again you have to rely on another company. Okay, there are some solutions similar to the to approach 3, but it's not necessarily from a company. It might be coming from a hardware tool. For example, there is a tool called TPM, Trusted Platform Module. It's a piece of hardware that most of laptops and hardwares in general nowadays have it. So this TPM, what it does is maintain, it has some registers, and within those registers, it maintains the hash form of your platform, your operating system, your hardware. And then once it is activated, any change within your hardware or platform, meaning the middleware, any change in that stack causes inconsistency between the hash values stored in these devices and the status of your system. And like that, you can capture there is a problem, there is a modification in this system. So the idea of how to overcome cloud security problems or infrastructure as a service security problems is to use TPMs. So basically, you can, for your virtual machines, you can you can use a TPM for each virtual machine, but we know that for each hardware there is one TPM, but on each hardware there are numerous virtual machines. Therefore, there are solutions to create virtual TPM, VTPM, that helps configuring TPM for each virtual machine. And if a virtual machine is tampered with, that can be captured by the TPM. So, okay, and then one other solution, because VTPM is absolutely less secure than hardware TPM, then the second idea is just use hardware systems that have active TPM and just allow your data to be stored and used on that dedicated servers in the cloud. Okay, so let's also talk about data security. So what we talked about in the previous slide was mostly compute security, basically virtual machine security. But let's see what are the threats for data. Specifically, when we talk about data, we have to consider 3 cases with data. Data at rest, then the data is stored on the disk and it doesn't do anything, but it can be compromised. The data in motion, while it is in transit, it's being transferred over the network, and while it is processed. So the 3 cases we have to consider. So now let's see what are the storage and computation security problems in infrastructure as a service clouds. So the problem is that, again, the main problem is that black box things. And the problem, more detailed problem, is that once it is black box, you cannot see what happens to your data. The problem is that the cloud not only stores your data, but also manages them. So ideally, it would be great if the cloud just stores our data but cannot manage them. Basically, the operations such as search, delete, copy, and other operations be done by ourselves, but the cloud is just as a dumb storage, dumb endless storage, we can say. So that would be ideal. Although that ideal is not in place, but we have to do something to simulate that situation to overcome security threats on the data. So I want to talk about one concept in data security, and that's called footprint. Basically, each operation that you do on data, that leaves some footprints. For example, copy is a footprint. So when you copy one file, that creates a footprint. When you copy part of, let's say, a text document to another document, that's a footprint. When you delete your file, even that is a footprint, because let's say in Windows it goes to the recycle bin, so that's a footprint of it. So the footprints creates a lot of security problems, because let's say you have one document or one file with sensitive data, and over time the data in this document can go anywhere, and then that footprint, is propagated, and that is a security problem. Specifically, there are two types of footprints: intentional footprints and unintentional footprints. So intentional footprints is like the ones that the user or the cloud provider is aware of it, or the user is aware that the cloud provider does that. For example, for each copy of your documents on cloud, there are multiple replicas for failover. This is an intentional footprint. Alternatively, an unintentional footprint is the footprints of your data that you do not have any control over and you are not aware of it. For example, when you delete a file on the cloud, your file is on the cloud, you delete a file and you think that it is deleted, but who knows, it might be accessible behind the scene, or that is an unintentional footprint, because you do not know what happened to your data, what is your data going. And generally, the unintentional data footprints are generally known as taints. And the example that I provided is just one case. There are a lot of other cases, like part of your file is copied to another file, and then you lose track of it, where it is going. All right, so as I said, the main problem is the cloud being a black box, and the users do not know how their data are managed in the cloud. And then different operations leaves different footprints on the data. And then these footprints can be misused, and the user does not have any control over them. Okay. So the problem that happens in this case is that how users can control their data in the cloud, specifically from unauthorized access. The main solutions that have been discussed in this context is user-side encryption. So basically, the problem is that clouds do not let us, at least current cloud systems, do not let us to manage our data. They do provide all the operations like copy, search, etc. Therefore, what we can do is encrypt the data and then give it to clouds. I want to remind you that many cloud providers offer encryption services. However, this encryption services is not user-side, it's cloud-side encryption, meaning that once you upload your data to cloud, they store it for you, they encrypt it for you, and store it. That is good, and it creates protection against external attackers, but that doesn't create protection against internal attackers, which is again one of the major concerns in the context of cloud. So user-side encryption, the difference is that the user owns the key to encrypt and decrypt data. So in this case, the user encrypts data before uploading it to the cloud. And then the key is remained by the user, and just the data is outsourced to the cloud, the encrypted data. And then, of course, there might be still taints, there might be still intentional or unintentional footprints, but the problem is that once you delete your key, none of those data is accessible. So this is also known as sanitization, basically making sure that you have the control and you can sanitize your data on the cloud. So basically, user-side encryption is the main solution so far for this problem. Another solution that can be even combined with this user-side encryption is sharding. What you can do if you have very sensitive data, you can split your data and store each piece of the data, shuffle them, and store each piece on a different cloud provider. This is suitable for multi-cloud situations. And then the combination of these two can be also used. You can do user-side encryption plus sharding and using multi-cloud solutions. All right. So I guess I talked about this case. If you want to do user-side encryption, you have to have a control key. That's the user key. And then you encrypt all the data using that control key, and then store the encrypted file on the cloud. Okay, and then another solution I also talked about, sharding and shuffling and storing on multiple clouds. Okay, so you can imagine a solution like this, that one file is sharded to multiple pieces and each piece is stored on a different cloud. And there might be an application on the user side that does this sharding transparent from the user. Another way to secure processing of the data, so basically what we discussed was mostly for data at rest, but for secure processing of the data, again, the solution that can be used is based on TPM. So basically, even if you encrypt your data, let me put it in this way. So when you encrypt your data, it's great. No one can access to it. That's good. But the problem is that you lose the ability to process it. If you use cloud just for storing data, that is fine. You don't need to process the data. But this is very rare. You at least need to search over your data, specifically text data. And sometimes you need to, let's say if you use infrastructure as a service cloud, you want to process your data on the cloud. And often it is not possible to process encrypted data. So you have to decrypt it. And once you decrypt it, it is there's a security problem. It's not under your control. So again, the solution that can be used is using TPM to remotely attest that the cloud node is using a secure hypervisor or not. So basically, once you make sure that the cloud is using a secure VM and the VM has not been compromised, then you can send your data to the cloud and decrypt it in that context and let it running in that virtual machine. Okay. So once you copy your data to a trusted VM, and then you know it is trusted because you can check that with TPM. Then you can decrypt your data in that context and use that VM because you are now sure about the VM being intact. Okay, so encrypt the control key using public key of the VM, send the control key to the trusted VM, and if it is a trusted VM, which means that it can pass the TPM test, then you can decrypt your data and do the processing. Okay. I guess I talked about sanitizing unintentional footprints. So once basically you revoke your key, then no one has access to your data, because even if it is in cloud insiders. Okay. So if your data have some taints, or there are some tools known as dynamic taint trackers that you can deploy on your VM, and for sensitive files, it tracks wherever it goes and makes sure that all the taints are sanitized. All right, so let's see about data security problems. I guess I mentioned some of these things. User cannot trust storage clouds for their data. The user solution is to use user-side encryption. However, when we talk about user-side encryption, there is some problems. Specifically, the lack of processing. The lack of processing is such as search. Search is particularly important because we often need to search over our data. Suppose that you store 1 TB of data on cloud and you cannot store it. Obviously, you cannot download the data every single time and then decrypt them, find your file, and encrypt them and put them on the cloud again. This is not viable. We need to search over data, at least search over data while they are on the cloud. And if they are encrypted, it is difficult to search the content specifically. Another problem with user-side encryption is that it is not transparent to the user. Yes, that is the problem. And of course, there is the overhead. This overhead is sometimes significant because most of the time when we talk about cloud, we want to access it using thin clients such as your mobile phone, your iPad, which do not have huge compute power, and they have limited energy source. So we want to do everything with a minimum energy consumption. Basically, low complexity algorithms need to be done. This is against many encryption tools that are generally taking a lot of execution time and energy to execute. Okay, so here we talk about a case study on how to perform search while the data is still in the encrypted form. Specifically, we may want to do search over encrypted keywords, or keyword search over encrypted data, or even more complex forms of search, such as search over wildcard search or regular expression form. For example, here all the keywords that starts with A or Andrew, and then in between there is one or more space. Then let's say the middle name is Stuart or S. So this form, you often do that using wildcards. But how to do that once the data is encrypted? How to do semantic search, meaning that you don't necessarily want that particular keyword, but the things similar to it. For example, when you search about Louisiana, maybe you are interested to documents that have the word New Orleans or Baton Rouge or Lafayette inside them. So this is called a semantic search, how to do that. So here's the case study for performing search over encrypted data, specifically regular expression search. I'm not going to the details of it. This was a project that we conducted in our lab, and this is the architecture for that. Okay. So another type of problem that we have is, or the security issue that we have is the authentication. So because companies that use cloud, or better to say that migrate to cloud, they have different access levels. So not all employees of the company have access to everything, to all services. So this creates a lot of problems. One of them is the authentication problem. How to make sure that a user has certain access levels or have access to certain services. One of the solutions that is used in this context is known as multi-factor authentication. For example, authentication using your IP address and or password and or personal information like date of birth and things like that, or for example using fingerprint and many methods like this. This is called multi-factor. More than one authentication method is used, and this can be applied uh, in a all together. Like for example, if you want to log in, you have to apply all of them, or what is more common is to apply that progressively. uh, Progressively means that in the first place you do not need to apply all your authentication methods, but you need to apply them when you want to access a higher level of a higher access level. Basically, when you need a higher access, you are asked for a more strict authentication. Let's say everyone with the IP address of my company, let's say, or my lab, can log into our cloud services. But if you want to create a VM, then you need, let's say, to use password. Then if you want to, create a cluster, then you need to, do a fingerprint and things like that. So this is called progressive multi-factor authentication, which is generally not user-friendly, and the users are it's frustrating. They keep being asked for different authentication methods. So there are some authentication like implicit authentication that you do not realize but you are authenticated, such as those that use geographical area. For example, if you are in certain areas or certain countries, you can or cannot use certain services. Or IP address, it's even more common that, for example, when you are in university and you want to purchase documents from digital libraries without authentication, you can do that. So this is called implicit authentication. So here's another project that we have had to do authentication in cloud in a progressive manner and using multi-factor authentication. So this is another case study that you can study. All right. Another type of threat that is important one in the context of cloud is multi-tenancy threat. So this is a kind of specific to cloud, or better to say, it kind of emerged out after the cloud technology became popular. So the thing is that when you share the hardware resources with other users, you have more exposure to attackers, and attackers can misuse this multi-tenancy um, to learn more about their target. Okay, so and actually the statistics shows that this type of attacks has a quite a big success rate. So more than 40% success rate is done in using multi-tenancy. Okay, so the attacker model, assuming the cloud is trustworthy, that's fine. There's no cloud insider attacker, and attacker is a malicious third party. So here our assumption is that our threat model is that we have some third party that legitimately uses cloud resources, but his or her purpose is not to use cloud resources, is to learn about you and your data. So they may attack your confidentiality or the availability of your data. Generally, they cannot do things with integrity, but mostly confidentiality and availability. So, so let's say in the case of availability, it is sufficient that the attacker finds the resource, the host that your VMs are located on, or co-locate their VM with your VM, and then they start they start a huge, let's say, I/O operation, copying gigabyte of data back and forth, and then that makes all the channels or the buses of the system of that physical host busy, and your VM, although it is isolated, but it wants to use the same I/O channels, and it cannot because they are always occupied. So this is an attack to the availability. Similarly, the confidentiality can be attacked too. Okay, so let's see the strategies that attackers can use more specifically. So basically, the attacker can map the cloud infrastructure and determine the co-residency of VMs. So basically, they can find where your VMs are and create VMs that co-reside with your VM on the same machine. And then once they do that, they try to attack the availability or confidentiality of your data. Okay. So there are many tools that attackers can use to do the network probing and know where your VM is allocated, and they may have some domain knowledge to use and basically make sure that their VMs are located on the same VM, on the same host as your VMs. So there are many techniques to do that. For example, and they may have some domain knowledge in doing that. For example, some domain knowledge is that if you use Xen hypervisor, that Xen hypervisor does not create more than 8 virtual machines on each host. And so that's a good piece of knowledge that you can know that that can help you to allocate your VM on your target machine. And then other information is like public and private IP and DNS address of the instance. So the attacker can use some tools and do reverse engineering to know the location of that VM, and then uses the knowledge that we mentioned in the previous point, the domain knowledge, and create instances, virtual machine instances on that hosts to basically co-reside with your VMs. Okay, there are some other techniques. For example, if they know when you are launching a VM, and they can launch the VM right after you, so that increases the chance that they are co-located on your on the same physical host. Or for example, if they can create the same VM type as yours. So generally, or at least in some cloud providers, similar instance types, similar VM instance types are created on the same host. So for example, if I know you are creating a small instance, I can create the same one, and it is very likely that they co-reside with your VM on the same machine. Okay, and then once they are co-located, they can do side channel attacks. For example, they can understand if you are communicating so much data, or when you are communicating so much data with other VMs or with your users, and this is a kind of attack to confidentiality. Or as I mentioned, they can do denial of service attacks, DOS attacks, by creating so much traffic on the same machine, on the same physical host. So what are the mitigation strategies in this multi-tenant environment? So basically, do not use patterns for allocating IP addresses, but this is not under our control. Generally, this is under the cloud control, but that would help to mislead the attackers. One easy solution is to not to use multi-tenancy. Basically, do not allow the other users to co-reside with your machines. This means that you use dedicated cloud services, which is possible, but it is generally very expensive. Okay, and then another important thing is to block unnecessary tools. So all of the solutions that we mentioned are not possible unless the attacker uses some tools such as Nmap and other tools. So you have to block all those tools or ports that those tools use on your VMs. Like that, they cannot do reverse engineering on your VMs. Okay, one other type of kind of problems in clouds that you should be aware of and think of solutions for it is to verify computation in the cloud. Again and again and again, the problem is that the cloud is a black box, and you do not have control over what is happening in there. So, in other words, in this scenario, in this threat model, the thing is that you run an application in the cloud, and the application is running, and you get the results. But who knows that computation was done correctly? Who knows that no one tampered with the results of your program, your application, in the last minute, just before returning that to the user? So how to verify that? So this is, my effort here is to make you aware of such type of problems. But then the solutions, of course, vary. Sometimes there is no certain solution. Sometimes you have to combine different solutions. But my effort here is just to make you aware of these types of problems that can happen, or types of the things that you should be sensitive about in the cloud context. Okay, so the threat model is that the attacker can, the cloud provider can be malicious, or the insider, and basically they tamper with the results of your processing. This is an example of attacking to integrity, and you should have solutions for it. So one solution that I found for this type of problem is randomized attestation. So basically, for some data inputs, so you run multiple instances of that data, and then you cross-check the results, at least for the portion of them, for some samples of it, and then make sure, and then basically from this cross-checking, find out if the results are matching or they are not matching, and then from there you can understand if there is possible compromises on your data or computation or not. All right, in this chapter we reviewed the security concerns in clouds and provided some solutions for important cloud security issues. Thank you and have a good day.